So good morning everyone. So let's discuss today on the Laplace transformation. So let's discuss on the Laplace transformation. So Laplace transformation. So we know that our system mx double dot plus cx dot plus kx, that was equal to maybe some forcing function. So we have seen already that there are different ways of doing the solution. We can also expand the f of t in case of the Fourier, and also some other functions like the t operator and all other things can be used. But here we will see another technique of the Laplace transformation. So in Laplace transformation, what are we doing exactly? So in that Laplace transformation, so first let's see what is the Laplace transformation. So Laplace transformation h of t, we can able to write it as h of lambda. Okay, so Laplace of h of t equal to Laplace of h. So and that is equal to integration 0 to infinity e to the power of minus lambda t into h of t dt. So we can see here we are doing the integration over the h of t, and we are multiplying with e to the power of lambda t, and we are then integrating from 0 to infinity. So in that case, what happening, this thing get converted into the lambda domain, as very similarly it was done in case of the Fourier domain transformation as well. It is converting into this thing. So like this way we can write this. So now we can see, so now let's think that if we are applying this Laplace transformation in that equation of motion, how this equation of motion can be converted. So first let's see, we are having Laplace of xt, so that can be written as x of lambda, which will be nothing but 0 to infinity e to the power of minus lambda t x of t dt. Okay, so if I just implemented lambda operator here, so I can write it lambda of mx double dot plus cx dot plus kx equal to Laplace of f of t. Okay, so once we are doing that, so in that case this is, and then Laplace can be coming like Laplace m of x double dot plus Laplace c of x dot plus Laplace k of x, that is equal to Laplace f of t. Okay, so now if we see, already we know that Laplace of x of t is this one. So now let's see what about Laplace of x dot t. So that we can write it x dot of lambda, and that will be 0 to infinity e to the power of minus lambda t x dot t dt. So now if we try to write it further, so we can get it. So x dot t dt integral minus this 0 to infinity, so this can be written as 0 to e to the power of minus lambda t x dot t can be ddt of xt dt. Okay, so can I write e to the power of minus lambda t into dxt? So now if you remember the formula for this, so we can say that, so this is basically u into v. So if you forget the formula of u into v, do not no problem. So we know du dt, that will be equal to u into dv plus v into du. So now if we just do some rearrangement, so u into dv should be equal to d into uv minus v into du. Integrate both the side, so I will get it u into v then minus v into du integration. Okay, and if I do the integration in like with limit, so a to b, then it will become also a to b, and it will be also a to b. So here if I do that similar way, so let's say this is my e to the power lambda t is my u and this is my dv. So then what can I write? E to the power of minus lambda t into x of t 0 to infinity minus integral 0 to infinity. So v is my, so dx dt, if it is dv, then v will be xt. So then it will become my xt, and you see du, u was e to the power of minus lambda t. So that means du will be minus lambda e to the power of minus lambda t dt. Okay, so I can get it e to the power of minus lambda t dt. Okay, so now if you see, what did I get from here? It so if I just erase that portion, just a minute. Yeah, so I can write it minus infinite into t into x to the power x infinity minus e to the power of minus 0 into x0 minus, and this term, if you see, this is what? This is nothing but my Laplace of xt. Okay, so now, and if you see that e to the power of minus lambda minus infinite t, that is nothing but 0, because if you think the e to the power function, that is exponentially decaying, so this will gives you 0. So we will have, and e to the power of minus 0 is 1. So I can write it that this term 0 to this, or maybe I can just rewrite it, sorry. So if I just write it, so Laplace of x dot t, that will be equal to minus x0 minus Laplacian of x of t. Okay, makes sense? Good. So if it makes sense, then let's go to the next slide and let's do the other one. So we see the two things. First of all, Laplace of x, that is nothing but integral 0 to infinity e to the power of minus lambda t xt dt. Okay, and Laplace of x dot, that will be equal to what just we have found, minus x0 minus x0 minus Laplace of xt dt. Okay, that we have already got. So what about the Laplace of x double dot t? So if I do Laplace of x double dot t, that will be also similar manner. I can do it minus lambda t d dt of x dot t dt. So that I can write it 0 to infinity e to the power of minus lambda t into d of x dot. So now if I just expanding that one in the very similar manner, what can I write? E to the power of minus lambda t into x dot 0 to infinity minus integral x dot t minus lambda, means multiplying with lambda into e to the power of lambda t. Yeah, sorry, here I made a small mistake actually. So once it is the du, there should be a lambda term should come here, so that will be minus lambda. So this minus will become plus, so this way it will become this. actually. So this one is little bit wrong. Yes, so this will be the scenario. So if you see here, this will be this. Okay, so we can get this. So now if I just substituting the full thing, so again I will have e to the power of minus infinite into t into x dot infinite minus e to the power of 0 t into x dot 0 minus, and if I see this one is nothing but 0 to infinity e to the power of minus infinity into x dot t dt. So this term is nothing but my Laplacian of x dot t, and we already know Laplacian of x dot t is this. So e to the power of minus, so and if you see e to the power of minus infinite t, that will be 0. So my this term will go to 0. So this portion becomes 0, then it will become x dot 0 plus lambda into, if I am just again substituting, x0 plus lambda into Laplacian of xt dt. So I can get x dot 0 plus, not plus, it will become minus lambda x0 plus lambda square Laplace of xt. Sorry, here it should not be xt dt, it should be xt. So now if I see the complete transformation, so I am having m times Laplace of x double dot plus c times Laplace of x dot plus k times Laplace of x equal to Laplace of f of t. What can I write? M times this one, so minus x dot 0 minus m lambda x0 plus m lambda square Laplace of xt plus c, actually it should be minus c x0 plus c lambda into Laplace of xt plus k into Laplace of xt, that will be equal to Laplace of f of t. So if I just take the Laplace of xt out, what can I write? M of lambda square minus plus c lambda plus k lambda into Laplace of x of t, that should be equal to Laplace of ft minus, so these all will go to that side, so m x dot 0 plus m lambda x0 plus c x dot 0, and I will get what is my Laplace transformation. So if I just write one step more, then it will become, so if I'm just taking a copy of that, m lambda square plus k into Laplacian of x of t, that will be equal to my Laplacian of f of t plus m x dot 0 plus m lambda x0 plus c x0 dot. Okay, so my Laplacian will be Laplacian of x of t will be equal to this full term. So you can also do like m this c lambda plus k to the power minus 1 into Laplace of f of t plus m x dot 0 plus m lambda x0 plus c x dot 0. So that you will get as like a Laplace transformation of that complete thing. Yes, so any question after that? Okay, so you can see here that once you are having a system and if you want to do the Laplace transformation and you know what are the forcing excitations, so you can take the Laplace of that forcing function. So Laplace of the forcing function will be like this. In similar manner, 0 to infinity e to the power of minus lambda t into f of t dt. So you know whatever is your dt, so that dt you know like how the forcing functions are there, so that is your f of t over the time domain, and you can convert it into the lambda domain, so you will get that spectrum. So you can able to get f of lambda t from here, and these are your initial conditions. So you can see the initial conditions are coming here, and for particular lambda you will get this full expression. Okay, so any question after that? So thank you very much. We are concluding here. Thank you.